हाय फ्रेंड्स, आई एम सिद्धार्थ। आज मैं आपके लिए 10th Gen शिफ्ट 2 का पेपर सॉल्व करने जा रहा हूँ। मुझे फीडबैक मिली +1 के स्टूडेंट से कि उन्हें रियल पेपर सॉल्व करके बहुत मज़ा आया और उन्होंने वीडियो वॉच किया, उसमें उनके कॉन्सेप्ट्स बहुत क्लियर हुए और उन्हें अच्छा लगा एंड दे वांट टू सी मोर वीडियोस। सो आई एम गिविंग यू द नेक्स्ट वीडियो एज पर द प्रॉमिस। और +2 के स्टूडेंट्स का ये बहुत अच्छा फीडबैक लगा मुझे कि दे सेड दैट हमारी स्पीड बहुत ड्रास्टिकली इंप्रूव हुई कॉन्सेप्ट्स के साथ। तो मैं आपके लिए ये पेपर आज सॉल्व करूंगा एंड माइंड इट, इफ यू लिसन दिस वेरी केयरफुली you could able to solve the whole paper +1 paper in just 20 minutes। इस बार शिफ्ट 2 में 13 क्वेश्चंस आए हैं +1 से। लास्ट टाइम 12 थे, इस बार 13 क्वेश्चंस आए हैं +1 से। सो लेट्स सी किस तरह के क्वेश्चंस हैं और मैं सबको ये कहूंगा कि आप पहले सारा पेपर ट्राई कर लें, सॉल्व कर लें। मैं आपको क्वेश्चन फ्लैश कर देता हूं, पॉज करके आप सॉल्व कर सकते हो एंड आफ्टर दैट यू कैन वॉच द वीडियो। ओके फ्रेंड्स, लेट्स रिव्यू द पेपर। राइट, फर्स्ट क्वेश्चन आपका हीट एंड थर्मोडायनेमिक्स से आया है, द पार्ट कैलोरीमीटर। सेकंड क्वेश्चन आपका मोमेंट ऑफ इनर्शिया पर है। थर्ड क्वेश्चन सिंपल वेक्टर्स है, बेसिक ऑफ वेक्टर्स। फोर्थ क्वेश्चन आपका वर्क एनर्जी थ्योरम पर है और फिफ्थ क्वेश्चन एरर्स पर है। सिक्स क्वेश्चन वेव्स से आया है और सेवेंथ क्वेश्चन ग्रेविटेशन और थोड़ा सा सेंटर ऑफ मास कॉन्सेप्ट यूज किया हुआ है। एट्थ क्वेश्चन आपका हीट एंड थर्मोडायनेमिक्स से है। नाइन्थ क्वेश्चन काइनेमेटिक्स एंड 10th क्वेश्चन रोटेशनल मोशन। 11th क्वेश्चन आपका फिर वेक्टर्स से है और 12th क्वेश्चन एसएचएम पर है और 13th क्वेश्चन भी एसएचएम पर है। दैट इज द फाइनल क्वेश्चन। राइट, नाउ वी स्टार्ट द पेपर, ऑल ऑफ यू। आफ्टर ट्राइंग ऑल द क्वेश्चंस केयरफुली, उसके बाद आप मेरा वीडियो देख सकते हैं एंड कैन फील द डिफरेंस। तो हम पहला क्वेश्चन देख लेते हैं। एज यू नो, ये क्वेश्चन थर्मोडायनेमिक्स से आया है, कैलोरीमीटर पार्ट से आया है। एक अननोन मेटल कैलोरीमीटर में डाला जाता है जिसके अंदर पानी भी है। फाइन, तो मेटल इज एट हाई टेम्परेचर, वाटर एंड कैलोरीमीटर इज एट लो टेम्परेचर। फाइनल टेम्परेचर इसके कहीं बीच में है, 21.5। तो मेटल हीट देगा और कैलोरीमीटर एंड वाटर हीट रिसीव करेगा। तो वी हैव टू राइट द फॉर्मूला अकॉर्डिंग टू दैट। वंस यू अंडरस्टैंड दिस, I'll write the formula. Delta Q is equal to mc delta theta. I'll use this formula. Now, heat given by the metal is equal to heat received by calorimeter and water. So I'll write up this one as mass of metal, specific heat of metal, delta theta is equal to mass of the water, specific heat of the water, delta theta, mass of the calorimeter, specific heat of calorimeter, delta theta. Right, this is the heat given and these two will receive the heat. Right, put down the values carefully now. Mind it, mass, here is mass, here is mass, so we can put the mass in grams. Never mind if this is in grams, this is in grams, this is in grams, we can put up that. Specific heat, if this one is in kilogram joule per kilogram per Kelvin, then all must be in the same units. Be careful regarding this part only, right? Otherwise small mistake can be done. Now put on the values. Start with the metal, 192 grams. Specific heat we have to find out. Change in temperature, the temperature varies from 100 degrees centigrade to 21.5 degrees centigrade, so it is 100 minus 21.5. it is equal to mass of water given as 240 grams. Specific heat of water, mind it, you have to put that in joule per kilogram per Kelvin, so it has to be 4200 into change in temperature 21.5 minus 8.4 plus mass of calorimeter, which is given as 128 grams. Specific heat of calorimeter 394 multiplied by 21.5 minus 8.4. and once you solve this, you get the specific heat value near to 918 or something like. This will be the right answer. I think we can solve this question easily, right? So the only point is to be noticed in this question is, don't worry about masses कि ये grams में है तो सबको kilograms में convert करना है. If this is in grams, it will work. Joule per kilogram per Kelvin, joule per kilogram per Kelvin, joule per kilogram per Kelvin. It will work, right? So this is question number 2. You see that these are two spheres. By default, they are solid spheres, if it is not mentioned. And this is a rod whose mass is m and length is 2r. So find the moment of inertia. You have to use parallel axis theorem starting from here. First thing, find the moment of inertia of the rod. It will be given as m into, I think you remember the formula, ml square by 12, right? So m 2r square by 12 plus, find the moment of inertia of the solid sphere about its center of mass. It is 2 by 5 mr square. Apply parallel axis theorem between these 2 points. This one is r, this one is r, so it will be plus m into 2r square, and by symmetry this part will have the same moment of inertia into 2, right? So take up this part as 1 by 3 plus 2 by 5 plus 4 into 2, so this will give you 22 by 5, 44 by 5 plus 1 by 3, 15, 5 plus, so it will give you 137 by 13. See question number 3. It's a simple question. Two vectors have equal magnitudes. Magnitude of a plus b is n times the magnitude of a minus b. Use this condition, just a little mathematics and this simple formula. Mind it, when it is a plus b, we use this. When it is a minus b, we use minus, right? So a and b have equal magnitudes. That means p and q are same. So using this, we go p square to p square cos theta is equal to n times p square plus p square minus 2p square cos theta of. I hope you can solve this question. Squaring, and very simple. That one is find the value of cos theta. It comes out to be this one, right? See the question number 4. It's a question based upon work energy. इतनी force apply की and displacement of 4 I cap is done. Initial kinetic energy is 3 joules. और पूछा गया what is the final kinetic energy. So we have to use work energy theorem. Work done is equal to change in kinetic energy, and work done is F dot S, which is equal to final minus initial. I hope you can take the dot product. It's very simple. I with I, it comes out to be 12. It is equal to final kinetic energy. We have to find out. Initial kinetic energy is given as, I think it is given as 3 joules, right? So final kinetic energy simply comes out to be 15 joules, right? Right? Look up to question number 5. इस क्वेश्चन की एक खासियत है, वॉल्यूम पर पूछा हुआ है, एरर्स पर क्वेश्चन है ये. Look up this one. Volume is pi r square h. We can simply write the formula first. Diameter is given as 12.6 and height is given as 34.2. If you find the volume as pi, diameter as 12.6, as you know that radius is half of diameter, so you can say d square upon 4 into height is taken as 34.2. If you find out this, the value comes out to be nearly 4260. This one, the volume comes out to be 4260. Then we find the errors. Mind it, there is no other value 4260. So you no need to find the error. You can simply give the answer as 3. Right? Okay, fine. Now I do some extra work. Suppose एक option और में 4260 होता, then we find the error. Error is to be found simply as, from this formula, delta V upon V is equal to 2 delta R upon R, right, plus delta H upon H, right. Delta R by R and delta D upon D is one and the same thing, right? So original volume we already know, 60, we can use that. 2 error in R, that is error in diameter, 0.1 upon original diameter, that is 12.6, plus error in height, 0.1, original height is 13.4.2, right? And solving this, we'll get this one, it's near to 80. So we see question number 6. Now mind it, fundamental frequency of closed organ pipe is given. Maximum frequency man can hear is 20 kilohertz. Asked is find the overtones. Number of overtones that can be heard by the person. Understand this one. Closed organ pipe has only odd harmonics, which means it has 1.5 kilohertz as the fundamental frequency and 20 kilohertz is the maximum limit of the man which he can hear. So if I multiply 15 with 10, it is 150, with 15 it is 225. Okay, so I'll take it as 14, it is 210, and 13. Okay, so 13, if I multiply this one with 13, it comes out to be 19.5 kilohertz. If I multiply this with 13, right, I can simply see that 13. So fundamental frequency is this, then it is third harmonic, fifth harmonic, seventh harmonic, ninth harmonic, 11th harmonic, and 13th harmonic, right? First one is the fundamental, this is not the overtone. The number of overtones are 1, 2, 3, 4, 5, 6. Mind it, total 30 up to 13th harmonics, but the number of overtones are only from 3 to 13. That comes out to be 6, right? So it comes out to be 6. Okay, we see question number 7 now. In this question, you know that there are two stars. Mind it, we'll assume them as point masses. Just for the sake, I have drawn them as spheres. They are distance of 2 into 10 raised to 11 meters. Each mass is given as 3 into 10 raised to 31 kgs each one. A meteoroid is fired from the center. We have to find the velocity so that it escapes into infinity. Conserve the energy in that way so that the mechanical energy becomes 0, right? So suppose a meteoroid has mass m, so we use potential energy between this and this, that is minus g m upon r, half of the distance. Same as with this one, right? And plus half mv square. So this should be equal to 0, right? I hope you can see that. Solve this question. We'll get the velocity as 2.8 raised to 5. Simple calculations after that, right? So now we see question number 8. It's a very simple question on thermodynamics, right? You can solve that in, I think, less than 30 seconds. Once you read the question, half mole of ideal monatomic gas, constant pressure, find the work done. The work done is P delta V, which is equal to NR delta T. Put on the values, N half moles is given, R is given to you, and delta T, change in temperature, is given to you, right? So approximately 280, 290 you can call it as. Answer comes out to be 291. Right? So let's see question number 9. We have to find position. So area under BT graph gives the position. I think area we can find out, right? So let's see question number 10. Now we can see that it's a massless rod of length 3L and has two masses attached at the end. We have to find the angular acceleration, right? We have to find the angular acceleration in this case. So let's draw the FBD. G, that is 2m naught G. Find the torque about point P. G, into L minus 4 m naught GL. It's simple, m naught GL, which is equal to I into alpha. So simply find the moment of inertia. Take them as a point masses. It is ml square 25. No, it's not 25. For ml square. It is 5 m naught into L square plus 2 m naught into 2L square. It is 4L square. Right? It is. So I think it comes out to be 8 plus 5, 13. So something divided by 13, G divided by 13. I will take the answer as first one. Right? So let's see question number 11. Actually, this question is a repetition. Again, same vector, same formula. Use this formula: R is equal to P square plus Q square plus 2PQ cos theta. Right, I'll use as R square. So in one case, you'll put P is equal to 2F, Q is equal to 3F. In the second case, you will put P is equal to 2F and Q is equal to 6F. As force Q is doubled, the resultant becomes 4R and resultant is R. I hope you can solve this equation. Put down these values, divide this, and answer comes out to be nearly 120 degrees. Right? So let's see question number 12. This is a good question, but somehow no answer matches with these options. So bonus marks is given for that. Good question, but goes vague. Right? Anyhow, I explain the question. Fine, I like to draw the diagram for this. Now you can see that a plastic bottle with a water is floating in water. So level will be same, minded. Water, inside water, level will be same. But when it is pressed down by X, it will extra submerged by this much volume. So extra point force, you have to find out that extra point force will come from this region, that is extra submerged volume into density of liquid into G is the restoring force, which is equal to total mass into acceleration, right? So we can find the extra submerged volume as pi r square area into X density of liquid into G is equal to total mass, which is possibly given as 310 ml of water. So we can find the volume of water as 310 ml of water, right? We can convert that into meter cube by multiplying with 10 to the minus 3 into density of liquid, right? Into acceleration can be written as omega square x, right? What I am taking this. So you can find the value of omega from here, cutting in this. You can find the value of omega simply. No need to find out, as things have got cancelled out. No answer is matching. Answer is coming out to be nearly 6. So let's see question number 13. Fine. You can see that amplitude is given, displacement is given, so we can use the formula and give an important condition: the magnitude of velocity is equal to the magnitude of acceleration. So we can put on this as v is equal to omega under root of a square minus x square, and acceleration is given as omega square x, I can use mod, is equal to velocity, right? So put on this value. Amplitude is given as 5 4 square, that comes out with 3w, 3 omega we can call it as. So this is 3 omega, and x is given as 4 centimeters. Omega square 4 is equal to 3 omega. So omega comes out to be 3 by 4, which is equal to 2 pi by t. So time period will come out to be 8 pi by 3, right? So hope that you are enjoying, and real questions face करके आपका confidence भी बढ़ रहा होगा. And you can also see that you can solve them very, very fast if you see this lectures carefully, right? Thank you very much.